we operated Dstatcom for power quality enhancement for the three-phase, four-wire distribution system. My name is Digvijay Kanse, working as assistant professor and currently pursuing PhD from Shivaji University, Kolhapur. The three-phase, four-wire distribution system are widely used for low voltage application such as homes, residentials, and complexes. The load connected to this distribution system might be three phase or single phase. The majority of three phase four wire system loads are nonlinear and unbalanced, resulting in high current harmonics and excess source neutral current. The third order neutral current has considerable influence on three phase four wire distribution system. The zero sequence current flowing through this three phase four wire system is three times that of each section's zero sequence component. So, the power quality concerns are caused by unbalanced load in the distribution system. Increased uses of power electronic devices in three-phase distribution system cause power quality challenges such as excessive reactive power, poor voltage control, unbalancing. Increased electricity consumption and the depletion of fuel sources have pushed power distribution companies to expand renewable energy penetration in the grid. Renewable energy has the potential to minimize power losses, reduce pollution, and enhance the voltage profile of utilities on the distribution side. The non-linear load connected at the distribution side ends up in power quality challenges and deteriorates electric power quality. Many investigators are motivated to enhance power quality supported renewable energy with the distribution system since there are non-linear loads. Various kinds of renewable energy sources includes photovoltaic cell, wind generation and fuel cell. Mainly the photovoltaic cell are used at the most, but the PV cell and the cell produce lower voltages. A solar cell can only be connected to a series to supply DC power. DC to DC booster is employed to extend the power level. The three-phase three-wire system and three-phase four-wire distribution system have serious power quality glitches due to different load that don't match the power distribution system line. A four-wire distribution system supplies single-phase load like fans, refrigerators, and other household appliances, computer load, SMPS, electric drives, etc. This leads to harmonic to the availability and enhances the neutral current. The neutral current passes through the neutral conductor and are the source of third harmonic within the distribution side. Dstatcom, that is distribution static compensator, is often used to abandon the effect of harmonics on load so that the current is sinusoidal. Renewable power sources are used to generate electricity and are supplied straight to the network to take care of the grid voltage and sturdiness. Compensation plays a big part in absorbing the network's most reactive power. The shunt power compensator, that is distribution static compensator, is connected in shunt at a common point, that is PCC, to pay both for the categories of the power quality problems. Now, this is distribution static compensator, which is a single phase shunt compensator. The V1 is inverter output voltage, VPCC, that is the voltage at point of common connection, and Vs, voltage at the source. The exchange of active and reactive power between the compensator and the grid happens depending on the amplitude and the phase of inverter voltage. If V1 is equal to VPCC, there is no exchange of any reactive power with the grid, and Dstatcom absorbs no reactive power. Suppose V1 is greater than VPCC, Dstatcom behaves like reactance, which is inductive in nature. From the transformer reactance of the Dstatcom, current flows in the grid and power generated is capacitive. For V1 less than VPCC, Dstatcom behaves like reactance, which is capacitive in nature. In this case, inductive power is absorbed by the compensator and the current direction is from grid to compensator. Thus, with help of shunt connected Dstatcom, one can have control over flow of power between grid and compensator. Thus, static synchronous compensator, which is shunt connection, is connected to three-phase distribution system with non-linear or unbalanced load. This STATCOM can provide shunt compensation by injecting current in the distribution system that varies linearly with the voltage. This distribution static compensator consists of voltage source inverter, DC link device required for energy storage, filters for eliminating the ripples present at the point of common coupling, and inductor or coupling transformer. So, it is shown the photovoltaic operated Dstatcom. Now, this is a Dstatcom which is connected in shunt across the non-linear or unbalanced load. The Dstatcom can provide shunt compensation that varies linearly with the voltage. It consists of voltage source inverter, DC link device required for the energy storage, ripple filters to reduce the ripples at the point of common coupling, then the transformer which is for isolation purpose or coupling. So this voltage source inverter can convert DC voltage stored in the energy storage device, that is DC link, to the output voltage AC in three phases. The generated voltage are in phase with each other by using coupling transformer and are connected to the grid. By altering the phase and magnitude at the output of shunt compensator, we may regulate the flow of active and reactive power between the shunt compensator and the grid. Nowadays, the renewable power sources become the first option to solve the generation dispersal problems. The voltage source converter, that is this STATCOM, fed on a large renewable source, that is PV and battery, is an effective and competent way to counteract load imbalances and reduce the total harmonic deviation. The Dstatcom is connected between the source and the load into the shunt form. A filter is used to ripple out the distortion occurring in the DC voltage in the voltage waveform at the common junction. The DC link capacitor of voltage source converter is set by the power generated by the Dstatcom, and which is given by the equation, that is VDC is equal to 2 into root 2 multiplied by line voltage divided by root 3 into M. The value of capacitor at the DC link is very much important in order to maintain a constant voltage across the voltage source converter. Here it is shown the PV equivalent circuit and the algorithm, that is maximum power point tracking algorithm, used in order to have the maximum power generated across the PV. The photovoltaic cell comprises of many configurations connected to series and parallel to generate the voltage and current that are essential to the system, that is to maintain the DC link voltage. The current flowing through the diode and the load is given by the equation, that is ID is equal to I sat into e raised to q VOC divided by A into K into T minus 1, and the current flowing is given as I is equal to IL, that is load current, minus I sat e raised to q VOC divided by A into K into T minus 1 minus VDC divided by RSH. I sat is the diode saturation current and electron of Q charge. IL is the current, photovoltaic current in amperes. VOC voltage in open circuit. A curve constant. K Boltzmann's constant. T fully operational temperature, and RSH is the shunt resistance. To obtain the maximum power from solar photovoltaic system, various methods are used. Some are maximum power point tracking. This paper discusses the perturb and observation algorithm. The flowchart of the perturb and observation table is shown. The perturb looks at the process of optimizing the output of high power emission that causes power wastage and see the effect of photovoltaic power output. Existing oscillations can be eliminated by discarding the step size, but it may take longer to touch the maximum power point. The goal of this approach is to compare real power with the past. When the difference between them is positive, the potential is increased by the magnitude of the action step, and maximum power point is finally reached when the difference is 0. The flowchart of P and Q system is shown. In order to generate the reference current for the control of voltage source converter, that is Dstatcom, this research includes the method of SRF theory, that is synchronous reference frame theory. The synchronous reference frame technique employs the rotating DQ frame concept. The phase lock loop is utilized to detect the voltage signal and produce sine and cosine signals. The conversion of current impulse into DQ frame. The signal conversions are shown. The present signals are then transformed back to ABC frame following the filtering. The current hysteresis controller receives this change signal in order to produce the gate pulse. The park, the park alteration technique is used to transform current data from links to the DQ frame. So the ABC is converted to DQ and from DQ to ABC. So here the ID and IQ current are found out first as shown in equation number 1. Then by using a low pass filter, IDDC and IQDC are the elements of DC separated and altered back to alpha beta system using reverse Park transformation as shown in equation number 2. And to gain the three phase current in ABC coordinate, the current equation are shown in equation number 3. So ABC to DQ and DQ to ABC, this is the conversion which is used in the synchronous reference frame current. Now we'll be discussing about the system of three phase 4-wire system without any compensation and with compensation. First, we'll be discussing about simulation results of three phase 4-wire system without Dstatcom. When Dstatcom is absent in the connection and if the system is consisting of non-linear load, the source current consists of harmonics and the current is non-sinusoidal. So which is shown in figure number A. The source current for three phase, that is ABC, is non-sinusoidal and consists of harmonics. Now our aim will be to make this current sinusoidal by reducing the harmonic contents present into the system. Now if you measure the harmonics for the current waveform without Dstatcom, total harmonic distortion for this source current comes to be around 6.24%. So which is very much high, that is harmonic content present into the system are very much high. So it is essential to reduce the harmonic contents present into the system. The power factor of the system without compensation, which is shown over here, that is power factor is round about 0.95, that means which is less than unity, that is 0.95 lagging. So it is essential to make or to increase the power factor approximately to unity. And before compensation, the active and reactive power present into the system are 22.26 kilowatt of active power and 7.01 kVAr of reactive power. So whenever there is Dstatcom absent into the system and the system consists of non-linear load, there is more generation of reactive power. If the generation of reactive power is more, the active power drops down and the system efficiency also drops down. That impacts the power quality of the system and there are more losses present into the system. So it is essential to reduce the reactive power present into the system, and this can be controlled when we connect the Dstatcom to the system in shunt across the load at point of common coupling. When we connect the Dstatcom, the source current becomes sinusoidal and the Dstatcom reduces the total harmonic distortion. The source voltage is sinusoidal after compensation. The load current and the load voltage results are shown in the figure. Since there is non-linear load present into the system, this load will have some of the harmonic present. So it is highly impossible to have a pure sinusoidal voltage and current across the load, since it is non-linear and has a reactive power load. The main aim of this Dstatcom is to reduce the harmonics at the source side. So few of the harmonics will be present across the load. Now this is the waveform of voltage at the point of common coupling, where we have connected the Dstatcom and the current at that point. If you see that after 0.05 seconds, the voltage and current are in phase with each other, thereby showing that the power factor of the circuit is unity. So if we see the power factor waveform across the source side, it is roughly or approximately unity, and the active power and reactive power is shown in the figure. Here the reactive power is being reduced from 7.01 kVR to 0.90 kVR, thereby maintaining the unity power factor. So when we connect the Dstatcom into the system, the reactive power is absorbed by the system and only the active power is flowed into the system. So if we see the total harmonic distortion of the source current after connecting the Dstatcom, it is 3.55%. That means before compensation the harmonics were about 6.24% in the source current, which is reduced to 3.55% by connecting the Dstatcom. Then the second figure shows the neutral current which are present across the load side and source side. So when the Dstatcom is absent, the source neutral current is very much high. It is greater than 2 amperes, but when we connect the Dstatcom, the source neutral current is reduced from 2 amperes to zero point 0.2 amperes. Thereby when we connect the Dstatcom, we can eliminate the neutral current which are rich in third harmonic. So this is the advantage of connecting Dstatcom in shunt across the load at point of common coupling. This waveform shows the voltage and current across the PV. A constant voltage of 415 volts is being generated by the PV, which is given to the voltage source converter to have a continuous operation of voltage source converter during day and night time. So the table represents the discussion of this system of 3-phase 4-wire system without Dstatcom and with Dstatcom. So if you compare the total harmonic distortion present into the system or source current before connecting the Dstatcom, it is 6.24%, and when we connect the Dstatcom, the total harmonic distortion in the source current is 3.55%. The active and reactive power is 22.26 kW and 7.01 kVR without Dstatcom, and active and reactive power with Dstatcom is 22.26 kW and 0.90 kVR. That means we can reduce the reactive power content present into the system by connecting the Dstatcom in shunt across the load at point of common coupling. So this is the advantage of Dstatcom in reducing the reactive power and increasing the power quality of the system. Thus, we can conclude that in order to address power quality issues, this study provides the three-phase voltage source converter for four-wire distribution system. Dstatcom and synchronous reference frame theory are used in the research on three-phase four-wire system. When there is non-linear load, the source total harmonic distortion is kept within IEEE standard, that is the harmonic is reduced from 6.24% to 3.55%, so which is well below the standards as specified by IEEE. And other power quality issues are reduced using Dstatcom and SRF theory for nonlinear loads includes power reactive power correction, harmonic reduction and load balancing. While the reactive power is rectified, the power factor remains constant at unity, which is shown in the waveforms of voltage and current at point of common conflict. Thus, with help of this STATCOM, we can reduce the power quality issues present into the three-phase four-wire distribution system caused due to the connection of non-linear loads. Thank you.